worksheet kind of talking about adding and subtracting fractions, multiplying, dividing.
I didn't really have any questions on it.
Okay. Stephen, is there one that you are, or more than one, really, it doesn't matter. Are there problems that you would like to see, Stephen?
Yeah, one of the fraction problems at the very end.
At the very end, yeah, those are good problems. So there were two different methods that you can use to simplify complex fractions. One method is to just look at each fraction, like each part of the fraction, the numerator and the denominator separately, and think about finding a common denominator for each individually. So I'm going to do 17 that method, and then I'll do 19 the second method. But if you look at the top of the fraction, so we're just focusing on this division bar. Really, it's division. That's what a fraction is doing. But that really dividing the numerator and the denominator and kind of being like a separation point. So if you look at the top, this is really thought about as 2 over 1. And just getting a common denominator for the top. If the second fraction has a 3, the common denominator has to be a 3. So that means I'm going to multiply the top by 3 so that it has a common denominator. So Stephen, do you know what that 2 over 1 would become?
6 over 3.
Yeah. So they have a common denominator. This becomes a 6. Excuse me. And then the x over 3 stays the same. So that's now 6 minus x over 3. So like we did a little bit of working with just those two small fractions there on the top, getting a common denominator. So then we have our big fraction bar, and we're going to do the same thing again, but this time with the denominator. So the one on the right has a 2. We're going to do the same thing, thinking about that as 1 over 1. So Stephen, what would that fraction become on the denominator?
2 over 2.
Yeah. And since it's 2 over 2, the x is already over 2. So now we have 2 plus x and over 2. So that's finding common denominator for the top separately from the denominator on the bottom. And again, this is method number 1 that was kind of discussed in the notes last week. So where do you go from here to finish simplifying the fraction? Jack, do you know where we would go from here to simplify the fraction?
Yeah, you would do 6 minus x over 3 times 2 over 2 plus x.
Yeah. So when you're dividing is really multiplying by the reciprocal. So we would take the denominator and flip it. That's what a reciprocal is. So it becomes 2 over 2 plus x. So this denominator is gone because we've changed it to multiplication. And then generally with fractions, we keep them in factored form. So the 2 that's being multiplied on top, we just put parentheses around that 6 minus x. We don't actually distribute that through. So factored form is simplified form. And we want things to be simplified all of the time in math. Our goal is always to simplify. Break it down as far as it can go. And then on the bottom, so we took the 2 to the top. We have the fraction and then the 3 with the x plus 2, or you could keep it as 2 plus x. So this would be your simplified complex fraction. Complex fraction is when we have multiple fractions already in something that is a fraction. But to get it out of that complex form, the goal is just to have one numerator and one denominator. And then we cannot break this down any further. The 2/3 is simplified. It can't be changed. And then each quantity in the parentheses is its own individual quantity. And if it's not the same, then you cannot cancel it. So that's one way that you can simplify. I'm going to go to number 19 and do the same thing, but I'm going to use the other method. So looking at 19, This one's a little different because we have quantities in the denominator and not just a number. It's still a complex fraction because you have two fractions on the top and then we have a separate fraction on the bottom. The fraction in the denominator here, this 1 over 2x minus 2. Stephen, do you know what you have to do first with that denominator, 2x minus 2, before we can think about finding a least common denominator?
Take out the 2.
Yeah.
For both.
So factor first, always the first step to factor. So if we take out a 2, we see we have 2 times x minus 1. So this one, I'm going to do thinking about this as a whole fraction. And I want to get the least common denominator of all of it. So if we look at the 3 different denominators, so we have an x minus 1, and then we have a 2 with an x minus 1. Jack, what would the least common denominator for the entire fraction be?
2x, x minus 1.
Right, so the 2x, so we got the 2, we have the x, and then they both have an x minus 1. So when we're finding a least common denominator, we're taking all the separate pieces, and together they make the least common denominator. So we're going to use the second method, and the second method uses the least common denominator of the entire fraction. We're going to multiply the top by that 2x times x minus 1, and we're going to multiply the bottom by that 2x times x minus 1. So when you have fractions, if you want to keep them equivalent, you do the same thing to the numerator as you would to the denominator. So I'm keeping it equivalent by doing the same thing to the top and the bottom. And then with this method, you're kind of asking yourself, what does the denominator have currently? So in the first one, we currently have an x. What is it missing so that it gets the least common denominator? And in this case, the first one is missing a 2, and it's also missing the x minus 1. So I'm going to multiply the current 2 by also another 2 and an x minus 1. So that's going to make it 4x and then minus 4. So think about, what does it have? What is it missing? So looking at this second fraction on the top, it has an x minus 1. So it's got the x minus 1 part, but it's missing the 2x. So that becomes plus 6x. Using this method, the denominator automatically cancels and we're just left with the numerator. And the reason it cancels is because I'm multiplying both parts of the entire fraction, numerator and denominator, by the least common denominator of the whole fraction. So now all I have on the top is the 4x minus 4, because we distributed that through, plus the 6x. So then on the bottom, thinking about the same thing, Stephen, what's missing from that denominator of 2 times x minus 1? What would the numerator need?
The numerator.
So look at
the x.
Yeah, just an x, exactly. So all it needs is an x because it has a 2, it has an x minus 1, so they kind of cancel away, and then we're just left with the 1 and the x. So again, using this method, it's kind of a little bit more scratch work in the actual problem, but once you do the little bit of scratch work, it changes pretty quickly to be just a single fraction. So if we add our like terms, we have 10x minus 4, and then it's just a lonely x on the bottom, because that's all the denominator of 2x minus 1, 2 times the quantity x minus 1. All it needed was just an x, because it had the rest of the denominator. So this right here is pretty close to being simplified. Our goal, though, to simplify is to have something factored completely. So just taking this one further step, Jack, what could we take out of the numerator so that this could be in factored form?
A 2.
Yeah, we could take a 2 out, and then we would end up with 5x minus 2, and then all divided by x. So when you look at a fraction, before you move to the next problem, ask yourself, is it simplified? Can you add or subtract anything? Can you combine anything? But then can it be factored? And if it can be factored, we do want to simplify it in its factored form. So anything in factored form is simplified form. So those are the two different ways that you can do a complex fraction. And it's kind of like whichever method you feel more comfortable with using. And sometimes I like using one versus the other, just depending on the type of fraction that you're given. So if we kind of look up at the top of this page, I think number 15 is a good problem, and I think there were a couple of questions that I had students emailing me last week on number 15. This is a 3-fraction problem. So if we're trying to subtract these quantities, we have to get a common denominator and factor first. And I think that third fraction was the one that was kind of getting a couple of students confused with having that x cubed minus 1. So the second one I would take out a 2. The first one actually can't be factored. And if I try and factor it, I have a 1. And 1 times 1 is the only thing that makes 1, and there's no way that 1 and 1 can add to be 1 as well. So that one doesn't break down or factor. But that third one, x cubed minus 1, that's a perfect cube. We factored these way back in chapter 5, but then we did a little review at the beginning of this chapter, which was a long time ago. Do you know how to factor that x cubed minus 1?
Yeah.
How would you factor that, Jack?
X minus 1 times x squared plus x plus 1.
And we called that the SOAP pattern. So because it's a difference of 2 cubes, it's a patterned way to factor. And that pattern was A, B with the same sign, and then A squared, the opposite sign, A times B, always a plus sign, and then B squared. And again, that goes back to chapter 5 in the notes. So it was a little while ago. But at the beginning of chapter 8, I think it was after the chapter 7 test, we talked about those factoring problems again. So it's the SOAP pattern of factoring, and the SOAP just represents the symbols that go in between the process of factoring. So Jack said x minus 1, so x, same sign, 1, and then that x squared, opposite of what we started with, and then always ends with a plus sign. So after you have it factored, Stephen, if you look at all those denominators, what would your least common denominator be?
2x minus 1 would be my best guess.
Okay, so you're close. There is.
And would you add the second denominator from the right one as well?
Exactly. So x squared plus x plus 1. So that's the goal for each fraction, to have that denominator. So any different factor that's on the bottom becomes part of the least common denominator. Once it's written down, then it's part of that least common denominator, so we don't ever want to repeat anything. Once the factor's there, it's part of that least common denominator. And then if you look at what you currently have, so the first fraction has x squared plus 2x plus 1. And think about, what does it need, or what is it missing? So Stephen, what would the numerator need for that first fraction with the 4x minus 1?
2x minus 1.
Yeah, nice. So we need a 2 and we need an x minus 1. So this requires a little bit of foiling. That really becomes 2x minus 2. And then if we FOIL this, looks like 8x squared and negative 10x and then a plus 2. So that's my new first fraction with the common denominator. There's a minus sign. I'm going to write the second 2x minus 1, x squared plus x plus 1. So pretty much I'm doing each fraction one at a time. So we've done the first fraction, now we're going to look at the middle fraction. And ask yourself that same question. So Stephen, the current denominator has a 2 and an x minus 1.
Then we need the x squared plus x plus 1.
Right, and there's only a 1 up there, so it's going to just stay as x squared plus x and then plus 1. So that one's kind of nice. And then our third fraction, again, writing that common denominator. So these are a little bit of work, but if you stay consistent and write each fraction with that denominator, with that thought process, then at least you have everything organized and set up. So our third fraction has the x minus 1. It has the x squared plus x plus 1. It's only missing a 2. So then we would have that 2x. So it's a pretty big problem. We've really expanded this to apply the common denominator to each piece. And then the last step is just to kind of combine all your like terms, except being really careful because this is subtraction. So the subtraction symbol goes to everything in that second fraction. So that's the one trick with subtraction, that if there's a subtraction sign in front of the fraction, it goes to each term of the numerator. So if you look across, Jack, the x squared terms, if we look across there, what does that become?
7x squared.
Yeah, so we have a 7x squared. And then the x terms, Jack, would be?
Negative 13x.
Yeah. And then the last, just the constant term?
Plus 1. Or minus 1.
I think you were right the first time. Because you have a positive 2 and a minus 1. Yeah. So again, just kind of looking all the way across the numerator. You're just looking and grabbing each one of the like terms, but making sure you're applying the sign in front of it. The denominator doesn't change because once we have a common denominator, that enables us to add the numerator together. We don't do anything with that common denominator. You just keep it the same. We're not multiplying that together. So very last step, after you find one fraction, you just want to make sure that it's simplified. Can it be factored? That would be the last thing to check in your problem. So just checking to see if I can factor this. 7 times 1 is 7. There's no way we can make a 13 with a 7 and a 1. So if you can't factor it, you don't have to simplify the problem anymore. It just stays as is, as that 7x squared minus 13x and then plus 1. But finding a common denominator is applied also in those complex fractions, but just thinking like each fraction, thinking one at a time and trying to find that common denominator of each fraction. Stephen, other problems that I can go over for you? I thought 15 was a good one because of that denominator being a cube.
Not really. I've mostly found checked most of the answers already. Those
Okay.
were just the problems that I was struggling with.
Okay, good. And Jack, you're good?
Yeah.
Yes, okay. So if you run into a problem that you didn't solve correctly, that you realized that something went wrong, feel free to shoot me an email or send me a little comment through the Google Classroom page, but I can always answer those. If this worksheet then it will be submitted on Google Classroom, so if you haven't submitted it at some point today, make sure you submit the worksheet, and I will be looking at them and kind of giving them a peek to make sure everybody feels good about rational operations, so adding, subtracting, multiplying, dividing fractions. So again, goal today is just to do an Edpuzzle, and an Edpuzzle is pretty much my notes from YouTube that I recorded, and then there are just questions throughout the notes just to make sure that I'm kind of checking for understanding as you're watching the video, since I can't really ask questions since we're not truly in the classroom. So it's the easiest way for me to kind of ask questions being on this virtual remote learning process that we're doing. Do either of you have other questions or concerns not rational operations related that you wanted to ask?
Not really.
No? Okay. Steven, you're good?
I feel like I did do the Yet puzzle yesterday, but my one question about it was, maybe it was intentional. Maybe I just looked at it wrong. But the way you did the extraneous solution, you asked the question like on the Yet puzzle
Mm-hmm.
about like 5-10 seconds before you explained it in the notes. Was that the intentional goal? Or?
Yes, because we've talked about extraneous solutions in the previous couple of chapters, so that was the goal, yes.
Okay.
So we talked about them in chapters 5, 6, and 7, and then it'll be applied again. But thinking about what an extraneous solution means, it's an extra solution, and why would it be an extra solution? So we did them with the log equations in the last chapter 7, because you cannot take the log of a negative number, which is why it's extraneous, and you cannot take the log of 0 because they don't exist. So that's what an extraneous solution is, a problem that usually, or an answer that does not work when you plug it back into the original problem. And like it's usually something with the equation as to why it's not working.
Okay.
Other questions?
Not really.
Okay. Well, you both have a wonderful day. I know I have another Zoom session set up closer to the end of the week, kind of working with equations and then starting to review for the Chapter 8 test. So I will see you guys, or not really see you, but I'll talk to you later in the at the end of the week.
All right.
And again, if you need anything, shoot me an email.
Okay.
Sounds good.
All right. Have a great day.
Okay.
You too.
Thanks.
Bye.